Hi everyone. In this lecture, we will see the circular convolution using graphical method. So basically, let's understand this approach by the help of one example. So here I have a question in which you have to perform circular convolution of two finite duration sequences, and the sequences are given as x1 of n is equal to 1 comma 2 comma minus 1 comma minus 2 comma 3 comma 1. So this term is what basically at n is equal to 0, right? And x2 of n is given as 3 comma 2 comma 1. So basically, in the graphical method, which is also known as concentric circle method, we represent the given sequences on concentric circles. Okay. So to find the circular convolution of two sequences x1 of n and x2 of n, follow these steps. So which steps you have to follow? Now let's see that step. Before that, we have already seen this point in the last lecture also, that the sequences must have the same number of samples, otherwise append zeros to the smaller sequences, right? So if you see x1 of n, it is fine given as what 1 comma 2 comma minus 1 minus 2 3 and 1. But if you focus on x2 of n, it is having less number of samples, right? So basically what you have to do, you have to append zeros. So 3 is there, 2 1. So here 6 samples are there, right? So we have to append 3 zeros, 0 0 0. So basically here x1 of n is of length 6 and x2 of n was of length 3. Therefore we append this 3 zeros to the sequence x2 of n, right? And then we can use the concentric circular method to find circular convolution. Clear? So this is our x1 of n and this is our x2 of n, which you have to remember. If you understood this, nothing is there later on, right? It is easy for you to plot the circles and all. So let's start now step by step. So this is required, so I will use this in between, don't worry. So basically let's talk about step 1. So in the step 1, transform n to m in x1 of n and x2 of n sequences, then plot them on a circle in anti-clockwise direction, right? So basically this is what step number 1. So basically you have to transform first, means change the index of n to m, and then plot the sequences x1 of m and x2 of m on a circle in anti-clockwise direction, right? In anti-clockwise direction. So I have plot this two circles, and at center I have written this circle I will use to represent x1 of m, and this I will use to represent x2 of m. It is clear? And this direction means what? We have to go anti-clockwise. So don't worry about this as of now, and you have to take care of what? These points, right? So basically you have to graph n samples of x1 of n basically as equally spaced point around the circle. Okay, this point should be equally spaced. So we already know, like, we have how many samples? 6 samples, right? So 6 equally spaced points you have to draw. See, 6 equally spaced points. So hope up to this you have drawn. Now let's start. So I'm going to represent x1 of m. So from here I will start x1 of 0. So x1 of 0. Now let's go anti-clockwise. So x1 of 1, x1 of 2, right? Then x1 of 3, then x1 of 4, then x1 of 5, right? And if you focus on x1 of n, this one, so now we are represented as x1 of m, right? So these points, see here, so at x1 of 0 the value is 1, so write 1 here, then the value is 2, so 2, go in anti-clockwise, so minus 1 value is there, then minus 2 is there, then 3 is there, then 1 is there. So x1 of m representation is done, right? Now let's focus on x2 of m. So x2 of m, it means what? Starting from here, so x2 of 0, now x2 of 1, x2 of 2, x2 of 3, x2 of 4 and x2 of 5. Let's write down the values. So starting value is what? 3. So here it is what? 3, then 2, then 1, then what? 0, 0, 0 boss, right? So this is what you should know. So I hope you understood how to draw this. So this is what step 1. So in the step 1, what we have to do? We have to basically transform n to m in x1 of n and x2 of m sequences. Then it will become what? x1 of m and x2 of m. Then you have to plot them on a circle in anti-clockwise direction. So plot is completed. Okay, let's go with me so it will be easy for you to understand. Fine. Now in the step 2, what you have to do? Let's focus on step number 2. Okay, so in step 2, basically fold one of the sequence by folding x2 of m to obtain x2 of minus m. So I'm going to fold one of the sequence. Let's say I'm folding x2 of m, so I will obtain what? x2 of minus m. So nothing, simply plot a circle, same circle, right? Equidistance points. Now we have to go in clockwise direction. See, this is what? A clockwise direction, because in the last step we draw that circle in anti-clockwise direction. So now I have to fold this, so I have to draw in clockwise direction. So this is what my x2 of 0. So I will go now clockwise direction. So x2 of 1, x2 of 2, x2 of 3, x2 of 4, x2 of 5. So we already know about what is the value of x2 of 0. So x2 of 0 boss, it is 3. Now x2 of 1 is what boss? x2 of 1 is 2, then x2 of 2 is what? 1, then we have 0, 0, 0. I hope this plot is clear to you. So this is what basically you did, x2 of minus m plot, and this direction is what? A clockwise direction, clockwise. Clear boss? Fine. Now let's go and understand step number 3. So in step 3, what we have to do? So to obtain the sequence x2 of q minus m subscript is what? N, rotates the sequence x2 of minus m, right? To obtain this, we have to rotate the sequence x2 of minus m q times, this q times, okay? And you have to understand, if this q is negative, then you have to rotate the sequence clockwise, and if the q is positive, you have to rotate the sequence counterclockwise. Okay, we'll see this, don't worry. This will come in the formula boss, right? In the formula we have seen n minus m in the circular convolution formula, but here we are standing at which instant? We are standing at n is equal to q instants. That is why I am using q here. Okay, so basically the given sequence are 6-point sequences. So if it is 6-point sequences, it means capital N value is what? 6. It means in the final result also we will get a 6 samples. So the sample of x3 of q at n is equal to q. I told you, right, we are standing at which instant? At n is equal to q. So this is basically given as x3 of q is equal to summation of x1 of m into x2 of q minus m subscript n, right? This is the formula. Now we already know the value of this n, which is 6, so we can transform this into this. So now x3 of n, because we are at this instant, this can be calculated as summation of x1 of m into x2 of n minus m, right? And here subscript, which is basically n. So this is what I hope you are aware about subscript and superscript, right? So this is what subscript n, so which is here in this quotient, the value is what? 6. So here 6, where the limit of m ranges from m is equal to 0 to 5. Okay, clear? Because the formula is what? M is equal to 0 to n minus 1, and the value of n is what? 6. So 6 minus 1, 5. Upper limit is 5, lower limit is 0. So hope this is clear to you. So it means what? We have to go for 6 samples. So let's start the actual calculation now. I hope these things are clear to you. So make a note of this, because I'm going to use this directly now. Fine. So let's go and let's start with n is equal to 0. Okay, boss. So let's say when n is equal to 0. So when n is equal to 0, x3 of n will be what? x3 of 0, which is nothing but x1 of m summation of x1 of m into x2 of this particular scenario, right? This particular term is nothing but 0 minus m is what? Minus m. We already know the plot for this, and we already know the plot for this. Clear? And we have to multiply this. Then you will get what? Summation of v0 of m, where the limit of m ranges from 0 to 5. Clear? So plot x1 of m. So this is what? The plot for x1 of m, that we already know. We have plotted this x1 of m already, and we have also plotted x2 of 0 minus m. Means what? x2 of minus m. This plot we have already plotted in step number 2. I hope you remember this, right? So I'm directly going to write the value. So here 3, 2, 1, 0, 0, 0, right? So these two plots are ready. Now you have to multiply this. So let's start from what? This should be x1, please use x1. Okay, so now x1 of 0 into x2 of 0, so 3 into 1. So at this point you will get basically 3. Clear? This is the resultant multiplication of this I'm writing here. Now let's see at this point. It's your wish, you can go at this point also, it's your wish. So let's go here. So x1 of 1 into this, so 2 into 0, so 0. Now check this point, minus 1 into 0, 0. Check this point, minus 2 into 0, 0. Check this point, 3 into 1, 3, and 1 into 2, 2. So this is what the representation of v0 of m. What is the formula, boss? What is the result? Summation of this v0 of m, okay, when the m ranges from 0 to 5, right? You got this instant values. So in order to calculate this x3 of 0, what you have to do? You have to simple calculate the sum of samples of this v0 of m, right? That will give you x3 of 0. That is what this formula is also saying. So 3 plus 2, 5 plus 3, 8. You got what, boss, here? 8. So 3 plus 2 plus 3, rest of the term is what? 0. So 8. Now we got x3 of 0 as 8. Clear? Now let's go for n is equal to 1, right? So when n is equal to 1, we got this term here. So what is required basically? x1 of m plot, which we already know this is x1 of m, use 1 1 here. I forgot that, sorry about that. Okay, so this is what basically our x1 of m plot that we already know, right? And you have to plot x2 of 1 minus m also. So remember one thing, in order to plot this, we already know x2 of 0 minus m, right? And here the value of n is what? 1, which is what? Positive. So what was the point we have covered? If the value is positive, so see here, if the value of q, so in the general expression here it is q, right? We have already seen that if the value of this q is positive, then rotate the sequence counterclockwise. It means what? Anti-clockwise. So let's go. We already know this sequence, so just rotate this anti-clockwise, 1 unit anti-clockwise. So if you see here, we were getting x2 of 0 in the previous case here. Now I am rotating this, so I will get x2 of 1 here, x2 of 0 here, now x2 of 1, x2 of 2, 3, 4, 5. Okay, so we basically what we did here, we rotated x2 of minus m by 1 unit anti-clockwise or counterclockwise. Simple. So we got this. So what is the value, boss? So x2 of 0 means 3, then 2, then 1, then 0, 0, 0. Okay, now multiply it, you will get what? This multiplication you will get v1 of m. So 1 into 2, 2, 2 into 3, 6, right? 0 into minus 1, 0, 0 into minus 2, 0, 0 into 3, 0, 1 into 1, 1. Now what is the result? x3 of 1 is equal to what? Summation of v1 of m over the limit of m ranges from 0 to 5. So sum up this, 6 plus 2, 8 plus 1, 9. So here x3 of 1 is what? Basically 9. Right? So sum of the samples of the v1 of m will give you what? x3 of 1, which is basically what? 9. So I hope this is also clear to you. So in the next, when you do n is equal to 2 term computation, then what you have to do? This again 1 unit anti-clockwise. Let's go and check that. So suppose when n is equal to 2, so this term is required and this is required. Am I right? So x1 of m plot is present here, x1 of m. Okay, 1 1, it is present here, right? Values also I have written because we saw this already, no need to do time waste here, right? Now you have to focus on x2 of 2 minus m. So we already know the plot of x2 of 1 minus m. Now same, we have to rotate in counterclockwise. Okay, so I rotated. So now at this point what you will get? x2 of 2. Earlier it was x2 of 1. Now rotate that 1 unit anti-clockwise. So x2 of 1 you will get here and x2 of 2 you will get here. So and x2 of 0 you will get at this location. So write down the value. So 3, 2, 1, 0, 0, 0. Multiply it. See, 2 into 2, 4 you will get here. 1 into 1, 1 you will get here. Right? 1 into 0, you will get 0 here. Then again 0, 0 is there. If you multiply this 0, 0, then 3 into minus 1. That is what? You will get minus 3. Now sum up this. See, the summation of this only will give you what? x3 of 2. So in order to calculate this x3 of 2, you have to sum up this. So 4 plus 1, 5 minus 3. What, boss? 2, right? 2. So x3 of 2 you got as 2, the value is 2. So hope this much is clear to you. Now we have to check at n is equal to 3, n is equal to 4, n is equal to 5. So when you check at n is equal to 3, simply this rotate one more time anti-clockwise. So let's go and check that. Okay. So when n is equal to 3, so when n is equal to 3, so x3 of 3 is equal to what? Summation of x1 of m into x2 of 3 minus m, right? Subscript 6, which, and the summation limit is what? M is equal to 0 to 5, which will be equal to what? Basically we are representing as summation of v3 of m, where the limit of m ranges from 0 to 5, this particular case. We already know the plot for this. So 1 1 1 1. Okay, we already know the plot of this. So x1 of m you have plotted, right? Now you have to plot x2 of 3 minus m. We already know x2 of 2 minus m. Just I am rotating that 1 unit to, in which direction, boss? In which direction? In counterclockwise, anti-clockwise direction. So rotating that. Now at this point what I will get? x2 of 3. Clear? And x2 of 2 you will get at this point. So, and here it is x2 of 0. So write down the value. So 3 3 2 1, then 0 0 0. Am I right? Multiply it. See here 0 into 1. Here also you will get 0. Here also you will get 0, because we are doing multiplication, right? Now 3 into minus 2, minus 6, boss. Now 2 into minus 1, minus 2. Now 2 into 1, 2. So overall minus 6 minus 2 plus 2. So overall you will get x3 of 3 is equal to what? Minus 6. I hope it is clear to you. No need to explain these things now. You are habituated of this. Now let's go and check for when n is equal to 5. So sorry, when n is equal to 4. So this is the formula to calculate. Okay, I am not explaining again and again similar kind of terminologies. So when n is equal to 4, just plot this and plot this. So this plot is ready. We already know about this plot, right? And then x2 of 4 minus m. So basically we know this x2 of 3 minus m, right? So rotate that anti-clockwise again. So when you rotate that, now at this point you will get x2 of 4. In last case you are getting here x2 of 3. So now I rotated 1 unit anti-clockwise. So I got this particular plot. Now write down the value, and x2 of 0 you are getting here. So value is what here? 3, then 2, then 1, then 0 0 0. Multiply it. So at this 3 points it will be 0 0 0 only. We already know. Now 3 into 3, 9. 2 into minus 2, minus 4. Now 1 into minus 1, minus 1. Now what you have to do? You have to sum up this, right? That will be equal to what? x3 of 4. So let's sum up. So 9 minus 4 minus 1. So overall what is the value? Plus 4, right? This is what? x3 of 4. Similar way, let's calculate our last sample for the output, which you will get basically at when n is equal to 5, right? So when n is equal to 5, this will become this terminology. What is required? x1 of m is required and x2 of this 5 minus m is required. So we already know the plot for this 1 1 1, right? We already know the plot for this, and in order to plot this, you already know x2 of 4 minus m. Just rotate that in anti-clockwise direction. You will get a new plot here, x2 of 5 you will get here now, because you rotated that. Now write down the value. So x2 of 0, the value is what? 3, then 2, then 1, then what? 0 0 0. multiply it. So at this 3 point you will get 0 0 0 only. Am I right? Then 3 into 1 3, then 2 into 3 6, then 1 into minus 2 minus 2, right? So now sum up this. So 6 plus 3 9, minus 2 is what? 7. So x3 of 5 is what? 7. I hope these things are clear to you. Now we got x3 of n, which is equal to what were the values we got? We got 8, then we got 9, 2, minus 6, 4 and 7, right? So x3 of n, so this is what? At n is equal to 0. This is our output. x3 of n is what? Basically this is what? A sequence obtained by circular convolution of x1 of n and x2 of n. This is how you have to calculate using the graphical method. Okay, this is what? Circular convolution using graphical method. I hope it is clear to you. Nothing was there. Okay, nothing to worry. You have to go step by step, then it is easy for you to understand these concepts. So if you have any doubt in this, you can ask in the comment section. Fine. Thanks for watching.